Hi, thanks for joining me for another installment of the Lab Report. I'm your host, Andrew Rams, and today I'd like to talk to you about getting the most out of the lubricants and oils used in vehicles and machinery. So if you're in an industry with a large fleet of vehicles and machinery, this is a crucial component in keeping costs under control. Prematurely changing oil will raise yearly expenses, and missing the signs of engine wear can be even more costly. So what do we need to look for in used oils and lubricants? Wear metals, such as copper and iron, may indicate wear from metal components rubbing against each other in an engine or any oil-wetted compartment. Boron, silicon, or sodium may indicate contamination from dirt or antifreeze, leading up to a failure. As well, additive elements such as calcium, phosphorus, and zinc are analyzed for depletion, which contributes to wear, since these elements contribute to certain key lubrication characteristics. And how do we analyze these inorganic components in organic solutions? Simple, spectrometers. Spectrometers were first used in these applications in the early to mid 1960s. Fun fact, they didn't have these fancy solid state detectors like we have in our current Optimas. So they actually captured the spectra on plates like these. So on these plates, they took the spectra and they compared the spectral bands that you can see to a reference plate. However, as demand for elements and samples grew over the years, advances in technology gave us inductively coupled plasma optical emission spectrometers, or ICP-OES for short, which could be used for oil analysis. There have been many improvements in ICP technology that have taken place over the years, with the most recent being the replacement of the helical load coil used to generate the plasma. The Optima 8000 and 8300 ICP-OES both utilize the new flat plate plasmic technology that replaces the traditional helical coil design used since the inception of inductively coupled plasma. With the new technology, two flat induction plates produce a plasma that is compact, dense, and robust. Plasma argon flow has been reduced to 10 liters per minute versus the typical 15 to 18 liters per minute used by helical systems for this application, which helps to reduce the cost of analysis while delivering exceptional analytical performance. The flat plate system also produces a flat bottom plasma that maximizes or minimizes the escape of sample and vapors from around the outside of the plasma, increasing the ease of organic sample analysis. Preparation of oil samples has been improved as well. Oil samples are typically diluted 1 to 10 with a kerosene-type solution. PerkinElmer can automate this process with one of our OilPrep Oil Diluters. These can be equipped with ultrasonic liquid level sensing and a 4 or 8 tip Verispan pipetting arm for rapid on-the-fly reformatting and diluting of samples in various sized vessels. The system utilizes multiple syringes along with disposable tips to increase sample throughput while eliminating carryover between samples and solvent waste. No rinsing is required. The sample preparation is done on a volume-to-volume basis, and throughput can be as high as 300 samples per hour. To help your Optima ICP keep up with that output, you need a way to rapidly introduce samples. The CTAC ASX Express system utilizes a high-speed vacuum pump in addition to the Optima's peristaltic pump. The 6-port valve allows the use of both pumps simultaneously, reducing total sample analysis time significantly, which also reduces the carbon buildup on the torch and the injector and helps increase stability over longer analysis runs. The use of the valve effectively divides the system into 2 stages. Okay? So the first, while the valve is in the load position, the vacuum pump rapidly fills the sample loop, while the ICP-OES peristaltic pump simultaneously transport carrier solution, keeping the plasma stable. In the second position, the loaded sample is pushed into the nebulizer for analysis via the carrier solution flowing through the ICP-OES peristaltic pump. At the same time, the autosampler probe is moved to the rinse station, and the uptake flow path is flushed with rinse solution via the vacuum pump. So both the Optima 8000 and 8300 ICP-OES instruments handle diluted oil matrices very easily. And the Optima 8300 increases sample throughput to 45 seconds per sample with little carryover between samples. The Optima 8300 is ideal for oil laboratories with moderate workloads. But for laboratories with a really heavy workload, an Optima 8300 with a PerkinElmer OilPrep Oil Diluter and CTAC ASX Express sample introduction system will help your lab meet your high throughput needs. So ask yourself, who has the best solutions for your oil analysis lab? Simple, PerkinElmer. So for further details, please visit the link below to see the full application note on the topics discussed in this video. Join us again soon when we submit our next lab report.